So, what if I told you that the best way to build something truly unbreakable is to make it actually feed on chaos? Sounds kind of wild, right? Well, today we're going to explore this really fascinating principle that connects a tiny, microscopic chemical reaction to a huge, powerful philosophy for how to thrive in a messy world. This idea right here, this is the heart of everything we're about to dive into. It really goes against what we're usually taught, that stress is bad, that it breaks things down. But what if, for the most powerful systems, disorder isn't the enemy at all? What if it's actually the fuel?
So that's the big question, isn't it? How on earth can chaos create strength? Well, the answer is hiding in a pretty unlikely place, the invisible world of molecular bonds. By understanding how the smallest things in the universe hold together, we can unlock a seriously powerful principle for building strength in pretty much everything we do.
To solve this puzzle, we first need to meet two little characters from the world of chemistry. Think of them as representing two totally different strategies for holding on when things get shaken up.
Okay, so on the one hand, you've got the single link. Imagine a simple bond, like a copper ion, just holding on to a single water molecule. It's a one-to-one connection. If that single link gets broken by some random jostling, poof, the water molecule just floats away. It's fragile. But then you have the claw. Now this is something else entirely. It's a much more complex molecule called a chelate. It doesn't just hold on with one link, no way. It has multiple arms that literally wrap around that copper ion. And get this bond is thousands of times stronger. But it's not just because it has more arms. The real secret isn't about brute force. It's about cleverly using the chaos around it.
So let's zoom in on the claw. We're about to uncover the really counterintuitive magic that makes its grip so incredibly powerful. It's a secret that has less to do with pure strength and everything to do with embracing the mess. This whole phenomenon is known as the Chelate Effect. And this right here is the crucial point. The claw's amazing strength comes from its ability to harness the random, messy energy of the system it's in. It literally turns disorder into a tool for creating stability. So, how does it actually do that?
All right, let's walk through this step by step, because this is where it gets really cool. First, picture the scene. The system is just a messy soup of molecules bouncing all over the place. That's what we call thermal noise. Then, step 2. The claw comes in and grabs the central ion. But here's the brilliant trade-off in step 3. By grabbing on, it kicks off a whole bunch of smaller molecules that were just loosely attached before. This leads to the real game changer. Step 4. By setting all those little molecules free, the overall chaos of the system, what scientists call entropy, goes way, way up. And because the universe just kind of prefers more chaos, the system wants to stay in this new, messier state. And that's step 5, the lock-in. The claw essentially buys its own stability by making the world around it a little bit messier.
Okay, so we've seen how this works in a chemical reaction, but this isn't just about chemistry, not by a long shot. This whole mechanism is a perfect illustration of a much broader, more powerful idea about how all kinds of complex systems can thrive.
And the term for this property is antifragile, a word coined by the writer Nassim Taleb. And it's important to know it goes beyond just being resilient or tough. See, a fragile object breaks under stress. A robust object just resists stress. But an antifragile system, it actually gains from stress. It feeds on volatility, on noise, on disorder, and it becomes stronger because of them. Sound familiar?
Here it is, the direct translation. That simple bond we talked about, that's a fragile system. The chelate claw, well, that's a perfect antifragile system. The thermal noise and random motion in the environment, that's just stress and disorder. And that final, super stable state the claw achieves, that is a textbook example of gaining from disorder. We've just translated a chemical reaction directly into a powerful philosophical principle.
This is such a powerful mental model to have. But, how does it actually apply outside of a science lab? Let's take this principle and see what it looks like in a more human context.
Okay, think about a teacher. A fragile teacher has memorized the textbook, they know the syllabus inside and out, but they have one path. If a student asks a really challenging, out-of-left-field question, a moment of disorder, their whole lesson plan can just shatter. But an anti-fragile teacher, they have a deep, interconnected web of knowledge. They've read history and science and art. For them, that same disruptive question isn't a threat, it's an opportunity. They can grab onto that disorder and use it to connect different ideas, forging a new, stronger, and way more memorable understanding for the whole class. Just like the chelate claw, they use the mess to build a more stable structure.
And that really leaves us with this final thought to chew on. The Chelate Effect reveals a profound secret about how the universe works. You can literally use disorder as a kind of currency to buy order. By strategically making the world a little bit messier in one area, you can create a point of almost unshakable strength in another. And that's a powerful idea to remember, whether you're building a molecule or building a life.